Okay, so this is the final problem from the Unit 11 review, which is another goat grazing problem. So again, this ties together a whole bunch of different area problems, essentially. So first, we've got, this time it's a 50-foot by 35-foot barn. We still got the fence extending on one side. And now the rope is 75 feet. So if the goat were to go directly this way, 75 feet, right along the edge of the barn, then there'd be 25 feet left over here. Let me make this a little bit better. So it's the 50 and then half of the 50. So something like this, where this part right here is 25 feet. And you could go this direction a full 75 feet. And if you just kind of roamed around up above, the perimeter of where he could reach would be that. So this is a semicircle there. Then he would get caught right here on the corner of the barn. The rope would get caught. So there'd only be an extra 25 feet to work with as he comes around, which means he would never make it down to here because that's 35 feet away. So he'd make it 25 feet down, but he would never be able to reach this extra 10 feet down here. So this is 10 feet. This is 25 feet. And then over on the other side, well, he's got 75 feet to work with, so he could go all the way to there, where this part right here is still part of the same circle with radius 75 feet. So what we've done is we've cut this into 4 parts, which I'll label region 1, 2, I'll do the triangle as 3, and this sector is 4. So let's work our way through the 4 regions. So area of region 1. Now you'll notice it's a quarter of a circle. The radius is 25. The reason I know it's a quarter is because that's a 90-degree angle. So it's 90 over 360, 1/4 of the area of a circle with radius 25. And if you plug that into a calculator, you'll get, in fact, I'll do it with you so I can show you a trick here so that you don't have to keep cutting and pasting. 90 over 360 times pi, what did I say, 25 squared. So that's going to be 490-ish, 0.874-ish. Okay, now I'm going to store that now as A. So I'm just going to remember I stored that as A. Okay, so area 2, well, that's half a circle, or 180 over 360 times, right, because this is 180 degrees here. So times pi r squared, but in this case the r is 75. So let me plug that one in. 180 divided by 360 times pi 75 squared. So we get 8835.729-ish, and I'm going to store that as B. So remember, this one's A, this one's B. Okay, let's look at region 3. So region 3, I'm going to need the base of this triangle. I can solve for the base easily enough, so I'm going to call this C, whatever my answer is for it. And that's going to be 1/2 the base times the height, which is 1/2 whatever the B is, times 35, because that's the height of the triangle, the right triangle that I have right there. So I need the base. Okay, well, I know that 35 squared plus B squared is going to be 75 squared because that thing's a right triangle. So if I were to solve for B, 75 squared minus 35 squared is 4,400. Oh, hold on one second. Okay. All right, so B squared is 4,400, so B is root 4,400. So this is root 4,400 right there. So then I can say that this area is 1/2 root 4,400 times 35. So let's plug that in. 0.5, or half, times root 4,400 times 35. And I'll store that as C. So, and I'll write it here just to have it. 1160. Whoop, 0.819 is what that would round to. Okay, and then region 4 is a sector. Well, region 4, I would need to know what this angle is. So it'd be a fraction of the circle's area, a circle with radius 75. So I need the theta. Well, notice that's a Z shape with the top and the bottom parallel, so this is also theta. So I can use that right triangle to figure out what theta is. Let's use the 35 here and the 75 so I don't have to use the root 4400. So this is opposite and adjacent, so that's sine. So then theta is going to be sine inverse of that thing, which is 27.818 roughly, but we'll get the full decimal for it here. Sine inverse 35 over 75. Oh, I'll bet you anything I'm not in the right mode yet. Yeah, degree mode. So now I can hit enter. So there's the full angle. And then I'm going to plug that in here. That's the theta. So that's over 360 times pi 75 squared. 1365. 0.5197, so that rounds up to 520. So then I've got these 4 areas here. Here's one of them, here's one of them, here's one of them, here's one of them. Let me store that last one as D. So I need to add them all together. So I want the sum of all of my areas. So I'm going to add up the 490, that thing, and that thing. But really on the calculator, I don't have to bother cutting and pasting them. I can just say, well, since I stored them as A, B, C, and D, I'll just add those together. And there's my answer. Now let me make sure I did this correctly. Yep, pretty sure I did. So 11,852.942. And that's what we'll put down here. 11,852.942. And then I think I was using feet up here. So this is square feet. All right. Hope that helps a little bit. Let me just double check one quick thing. I want to make sure that the C was done properly. Yep, we're all good. All right. And that's it. Okay, I'll see you guys later.